This is Team 1C. Today, we are going to discuss the performance of nail polish based on 5 criteria as well as comparing its performance with other brands in the blue color. The first criterion is that the nail polish should stay on the brush for at least 3 seconds to avoid drips before application. To test out this criterion, we use the same brush as our control variable and 2 different kinds of nail polish. The brush was dipped into the different nail polish, then lifted up, and the time for each drop was observed. We found that the time for our nail polish is 3.73 for the red one and 2.25 seconds for the blue one. From the result, the red nail polish has a better performance than the blue one.
To ensure the nail polish stays on the brush, it is designed to be viscous and adhesive. The high viscosity adhesion of our complex fluid system is due to the cooperation of non-linear polymers and solvent. Polymers have larger interactions between each other. Combining with solvent would further increase these interactions, which blocks movement of molecules, thus raising the viscosity. Furthermore, the resin has functional groups such as amine and sulfoxide, which makes this easier to form hydrogen bonds, allowing better adhesion.
The second criterion is that it should be easily applied, forming a thin, uniform, and smooth film. In normal applications, a maximum of 2 layers should be required to obtain a film of optimal thickness. Hence, the uniform region should be over 50% in one go. To test this, we brushed 2 fake nails once with different nail polish. The length of the fake nail was 2.3 cm and the uniform region of the red and blue nails were found to be 1.9 and 1.1 cm in length, indicating uniform region proportion of 82.6 and 47.8% respectively. Based off these results, our chosen product applies a better film than the blue nail polish. To ensure a uniform film, the nail polish is designed to be shear thinning. This is a result of a long linear polymer structure cooperating with the plasticizer. When being sheared, the polymers are disentangled and oriented. The plasticizer acts as an intermolecular lubricant, decreasing the interaction between polymers. This decreases the viscosity, allowing it to be easily spread into a thin film. In addition, nitrocellulose and the solvent contribute to film forming. When being applied, the solvent evaporates and makes the polymer sol becomes a gel, forming a thin film.
The third criterion is that the volatility of the nail polish should be low enough to allow a film to properly form on the nail but high enough to dry within 8 to 10 minutes. To test this, our nail polish was poured and spread out on a clear glass panel with the help of a brush under room temperature. We pressed onto nail polish every minute to observe whether fingerprint occurs. This testing area was made large enough for at least 10 fingerprints, since the nail polish should be dried within 10 minutes. No material was transferred to finger after 9 minutes with no fingerprint observed for the ride. Thus, our nail polish satisfied the criteria. On the other hand, the blue nail polish was not found completely dry after 11 minutes. From the drying aspect, our chosen product performs better than the blue nail polish.
The fourth performance criterion of a good nail polish is that its constituents should be suspended homogeneously over time. This is important as uniform color would be more desirable to customers in comparison with one where there is sedimentation on the bottom of a bottle as a result of sitting in storage and shelves. To perform an experiment that could simulate a long timescale, the bottles of nail polish were placed in a thermos while submerged in water with temperatures varying from 50 to 75 degrees Celsius. The temperature was measured every 1 hour to ensure it was within the range, as well as the photo taken every 4 hours. The following are pictures of a nail polish over time. As we can see, there isn't much change to the homogeneity of a solution. However, after 16 hours, the blue nail polish demonstrates a small degree of sedimentation. Our nail polish utilizes silica particles which create a thixotropic system, which builds enough viscosity to discourage pigment settling. Steariconium hectorite is also used as a suspending agent which attaches onto the surface of pigment molecules, making them hydrophobic, raising the degree of dispersion.
The final criterion is the flexibility of nail polish. In daily life, nail may encounter accidental bending up to 90 degrees, so the film formed by nail polish should withstand bending to 90 degrees without cracking. We designed the following experiment to test the flexibility of these two nail polishes. In this experiment, nail polish was applied to a fake nail. After it has completely dried out, the fake nail was bent to 90 degrees. The results showed that both nail polishes were able to endure 90 degrees bending, which indicated that these two nail polishes are both flexible enough for daily usage. The flexibility of nail polish is a result of plasticizer. The plasticizer molecules increase the distance between polymer molecules after being added to the solution, which decreases the intermolecular forces between polymer molecules. As a result, the film of nail polish is less likely to crack or peel from nails.
From the experiments performed, we can conclude that our nail polish satisfied all of these performance criteria as well as outperforming a rival product. Here are our reference lists. Thank you for watching.